Okay, too. So let's come back and take a look at what are the methods that we can use to collect gases. Okay, so the two main consideration to think about when you are choosing a method to collect gas is whether or not the gas is soluble in water or not. Okay, and also the density of the gas compared to air. So, for example, I give an example of a gas that is soluble in water. Ammonia. Ammonia is soluble in water. If it's soluble in water, right, then you wouldn't want to go and use displacement of water already. Okay, why? Because if you use it, then all the ammonia will be dissolved in the water. There's no ammonia left for you to collect already. Okay, so displacement of water is only for soluble, insoluble gases. Okay, displacement of water is only for insoluble gases. Then what if something is soluble in water leh? Then you have to consider the density of the gas compared to air. So for upward delivery, we use it for gases that are less dense than air, okay, so they can float all the way up. For downward delivery, use it for gases that are more dense than air, okay, so they can sink down. Okay, if you need to copy this, you can pause the video and copy first. Okay, later we'll look at the diagrams for how displacement of water, upward delivery, and downward delivery look like. Okay. So for upward delivery, okay, can you recall why is it used for? Okay, so let's continue. So there's a upward delivery of gas. This method we use it for gases that are less dense than air. Okay, so why if the you need to copy this, you can try and draw this onto your question 1.4. Okay, part I. Okay, you can draw this diagram inside there. Okay, but of course it's not art class, so you don't have to draw until very nice. Okay, all this pointy edge, we don't really need. Okay, you can just draw a nice little rectangle and then you can just label it gas jar. Yeah, it's good enough already. Okay, gas jar. The more important part is to go and label what is it. Okay, so for uh, upward delivery of gas, we use it for gases that are less dense than air. Why? Because the gas, if it's if it's less dense than air, what happened to it? It will just come in and then it will go up. And then after that, it's less dense, right? So while the gas is inside here already, okay, there's still air here. Okay, this gas will not sink. Okay, you will stay floating above the air. Okay, it will not sink downwards. Can because it's less dense than air, what? So you can actually collect it this way. Okay, the other way. Okay, so A2, there's another method, the downward delivery of gas. Okay, so for this method, we use for gases that are more dense, more dense than air. The concept is the same. Okay, the concept is the same. Why? Because for this case, let's say if we were to pass the gas into the gas jar, since the gas is more dense, right? Okay, and this part here is air. What happens is that it will not float, lah. Okay, it will just stay at the bottom of the gas jar. Okay, so this is how you can collect gases that are more dense than air. Okay, the next one, displacement of water. So this we only use it for gases that are insoluble in water. Okay, so for insoluble gases. Okay, so this is how it looks like. You can also sketch it down. Uh, for this case, initially the gas jar is completely filled with water, and okay, it's all water. But as you bubble the gas, okay, into the delivery tube, what happens is that the water will be displaced. Okay, you will push water downwards. Okay, and then water will just move out of the gas jar. Okay, and eventually this is probably halfway through the collection already. You get this portion here is the gas, which is insoluble in water, and then the water level can drop after that. Okay, last bit. How can you collect and measure a small sample of gas? So previously, you can see for upward delivery, downward delivery, and displacement of water, actually there's no marking, right? There's no marking on the gas jar at all. Okay, so we cannot really measure how much gas that we produce. So what can we use to measure the volume of gas is actually a gas syringe. Okay, this is called a gas syringe. Just take note that for a gas syringe, this part here is called a barrel. Okay, and then we have a plunger. So I connect this part to whatever gas is coming in. Okay, and then of course I'll just fill it up with the gas. All these are little lines. So actually, in the exam, you it's more important again to label. Okay, label the whole thing. Okay, is label the whole thing as a gas syringe. Syringe. Okay, correct spelling. Can? Okay, too. So let's continue. Question one. Okay, so for this question, the the first thing I want to ask you all is which method of gas collection is this? Okay, you can pause the video and think about it. Okay, so this is actually displacement of water, right? Displacement of water. And we use displacement of water only for insoluble gases. Okay, so as long as it's soluble, I cannot use this already. Now with that fact, actually, if you go down to the table, you can actually zoom into one column, right? This part on solubility. So as long as it is soluble in water, then I cannot use this method already, what? Okay, so the answer will be C, because it's very soluble. Okay, everything else, as long as insoluble, okay, or even very, 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 very slightly soluble only, we can still use displacement of water. Okay, next one, gas X is less dense than air, and how can you collect if it is very soluble? Okay, the very fact that it is, okay, so the very fact that it is very soluble in water means that actually I cannot use displacement of water already. So this will be out. So what's left is either upward or downward delivery. Okay, but in order to decide whether or not to use upward or downward, you have to compare the density, right? If it's less dense than air, means it will tend to float. Okay, it will float above air. If that's the case, then we have to use upward delivery. Okay, so that the gas can come in, you can collect the gas above the air. Okay, air is at the bottom. Okay, so upward delivery. See, can? Okay, so if that's the case, then congratulations on finishing the HPL and have a very good afternoon. Okay, A2. Bye bye.